Hello and welcome to Water Quality. In this video I'm going to go over the raindrop problem, which is based on the open system equations that we derived in a previous video. Okay, so we're going to start with the raindrop in the atmosphere. Let me get my correct pen. Okay, and the raindrop consists of pure water, but it's going to interact with CO2 gas in the atmosphere and form the carbonate system species. This will include H2CO3 star, bicarbonate, which is carbonic acid, bicarbonate, and carbonate. So this is an open system problem, which means that the water is in equilibrium with atmospheric CO2 or CO2 gas in the atmosphere. So I follow a certain kind of procedure when solving these kinds of problems. First, I'm going to write out the reactions. And the reactions include carbonic acid, H2CO3 star, dissociating and donating a proton and forming bicarbonate. The constant that goes with this is Ka1, because carbonic acid is a diprotic acid, and this is 10 to the minus 6.3. The second weak acid reaction I'm going to include is for bicarbonate, because it's also an acid, and it can dissociate and donate a proton and form carbonate. And the equilibrium constant for that is 10 to the minus 10.3. I'm also going to include water, which is also a weak acid because it can donate a proton and form hydroxide. And I call that the equilibrium constant Kw at 10 to the minus 14. The next step in my process is to write out the mass balance equation, which is CtCO3, and this includes all of my carbonic acid species. And so I have H2CO3 star, bicarbonate, HCO3 minus, carbonate, CO3 2 minus. And it's important to note that because this is an open system, this is not constant, because CO2 can come into and go out of our raindrop. So it can change depending on the conditions. Next, I'm going to write out the charge balance. So the only positive ions I have are hydrogen ion. And then on the negative side, I have hydroxide, bicarbonate, and carbonate. And I'm going to put a 2 in front of carbonate because it has a charge of 2 minus. My variable, or what I'm solving for here, because I'm looking for the pH, so I'm going to keep pH, or H plus, as a variable in this equation. And then I'll substitute in for hydroxide 10 to the minus 14 over H plus. For the bicarbonate, I'm going to use the open system expression I derived previously, which is 10 to the minus 11.3 over H plus. And then the 2 times, and then the carbonate expression is 10 to the minus 21.6 over H plus squared. Now it's important to note that if I had, I'm kind of assuming PCO2 is equal to 10 to the minus 3.5 atmospheres, and temperature is equal to 25 degrees C. If those assumptions change, I would just need to derive new expressions for the open system equations. Okay, so I can put this into solver on my calculator or use MATLAB or Excel, and I solve for H plus and get 10 to the minus 5.65, or a pH of 5.65, and that is our solution.